Any other questions? Okay, so why don't we start? I'm gonna unmute you just in case there's no random noises. So I will then stop at some point like I did in lecture 1 and try to get your questions again. So let's have a lecture. Let's start with the lecture today. So those of you who joined late, the labs will start this week. Go to your zone, check when your schedule is, and tomorrow I will communicate the Zoom links and what you need to do to join the lab. Okay, so let's start with the lecture. Those of you who would like to put the camera on, please do. Those of you who don't want to, you don't have to, but it's nice for me to see some faces when I'm teaching other than looking just at the thank you. It's really helpful, thank you. So those who don't mind, but those who mind, please turn it off. It's not necessary. Okay, so what we're gonna do today, we're gonna finally start with the material. So let me share the screen so we can start coding. As I promised the student, this course we really start from the beginning. It may be fast for those who never programmed before. It may be too slow for those who programmed before. That's just the nature of the course. So try to be patient. Hopefully all of you will get something from it eventually. So let's share the screen. Here I'm sharing the screen. And so let's, just in case some of you missed the first lecture, at the very end of the first lecture, and based on the questions that I got from on a Brightspace, some of you did not even install Python. So again, in case you didn't, just go on a webpage, python.org, and go to downloads and click on whatever version you find there, download it, click on it. It's going to install Python, and it's going to install a little piece of software called idle that I will use because it simply comes pre-installed. If you want to use anything else, please go ahead. I get lots of questions about what should I use. It really is not important. Pick whatever you like. I personally, when I code, I just pick any editor and run Python in the terminal. If you know what that means. If you doesn't really matter. I think that's what you're going to do actually in your next course in ITI 1121. You will be writing code in a plain text editor or some editor that at least recognizes the syntax of the language, and you're going to be running Java in the terminal. Just if you know what to expect for those of you who are interested. But in this course, because idle comes pre-installed with Python, we're going to use that at least in the beginning. I will see later on. And again, it doesn't matter as long as you know how to solve computational problems. All right. So if you install this, find a software on your computer that this thing will install. It's called idle. And pick 3.8 if that's what got installed, or whatever you find, as long as it starts with 3. And it's going to open this window that I explained the last time. This is Python shell. You know that you're in the shell because you see these 3 arrows that are telling you that you are actually, how should I put it? Let's say this is your window into Python, okay? This is the way for you to directly communicate with Python or Python engine if you like. This window, a shell, is really for the programmer. So you as a programmer can use it to figure out what Python knows, to test some things and so on. But once you're ready to write your code and once you're ready to save it for future use, you should open a new file, write your code like we did last time. We wrote the simplest possible code. Hello world, between the quotes. That is your that is a program. You save it. Let's call this lecture2.py. You give a name to your program, then use a dot, and then you save it with extension py, which stands for Python. Once you save the program, and if you put a cursor on this window, so the window where your code is, and you press run module, it's going to run your first program, okay? It's going to show the result of the run in Python shell. That's where you're gonna see the result of running your program. But since we are just learning and we are at the very beginning, instead of writing the code that we are going to save, because really we are not solving any problem, we are not making a game, we are not doing anything that we necessarily, and if we are not developing code that we necessarily want to save, let's just go back here in the shell and actually write the lines of code there. So we learned what Python already knows. What we learned and seen in last class is that Python has a command, and proper name for that is a function called print. The way to use it is to type print, and then inside of the parentheses and between the quotes. So in Python and all the other programming languages, if you want some text to be part of your code, or if you want to, for example, present a text or type the text, then you put it between the quotes, and text is called string. Okay, we're gonna get to that, more to that, but for now, let's just leave it at that. So what should we have seen that if we put some text here, something like that, Python should type it. And I guess you can use a proper grammar. I'm using lowercase out of laziness, and you can see that Python knows this print command. You may wonder, how do I know what Python knows, right? Why will this work? If I do print, will that work? Well, it tells you that doesn't know. So already from the beginning, try to get useful information from the errors that you get. So look, in particular, look at this last line. It's telling you that it doesn't know this name, capital print. Okay, so simply doesn't have that command, or in other words, doesn't have a function print with capital P. Okay, so again, we go back to the question, how do I know what Python knows? And here's a very useful command that you're going to be using throughout the semester that's going to tell you what are the most basic functions, commands, whatever word is used. Well, actually, let's stick to the words that are in the textbook because you're going to get used to it. So what are the functions that Python already has that I can use? So what are the functions that somebody else developed and I can use them? So we learned that somebody else developed a function called print with a lowercase p. Okay, so let's see what else. So there is a function called dir. You make function calls. In other words, you are calling functions always by their name. Then you always open parentheses, close parentheses, and then it changes what's inside of these parentheses. Dir means like a directory. Tell me what's inside of this. So this function lists what is known in particular Python library. What are the functions that already exist? If you want to know what comes pre-installed in the most basic Python, then you do dir and open parentheses, close parentheses, and what you're going to put here, at first it doesn't make much sense. Well, I'm not saying it's going to make much sense towards the end either, right? This is not necessarily intuitive syntax. You do underscore, underscore, built-ins, underscore, underscore. You put that, okay, in the parentheses. So 2 underscore, built-ins, 2 underscores, and you press enter. So it looks like I misspelled something here. Underscore, underscore, built-ins, I misspelled it. Okay, so built-ins, and now it tells you, here it is, it looks you big, but actually it's not. That's it. And in addition, it's actually smaller than it looks, because I'm going to ask you, at least for now, until we get to object-oriented programming, to ignore everything that starts with capital letters. So all of this at the beginning and everything that starts with underscore, underscore. So we get here actually. So these are your built-in functions. That's it, okay? So these are the functions. There's a very small number of functions in core Python. There are other functions in separate libraries. You have those who join me in the tutorial. You have seen that there are functions in the library turtles. Then there is a library, math library, where you have square roots and logarithms and so on. So there are many libraries, but in a core Python, these are all the functions that you have. For example, you see that the print is there. We have learned that print is there. Okay, so looking at these functions, they're all there. You can use them. In other words, you can call a function. Some of them you can guess what they are, right? So ABS, what would ABS be? Normally in the class, I would immediately have somebody answering that this is absolute value, right? So ABS, remember, you always call the function by the function name. You open parentheses, close parentheses. In between the parentheses, you give a data that that function needs. So in this case, we can even guess. If you're asking for an absolute value of a number, clearly you have to give a number to the function that you want an absolute value of. So we can do something like minus 2.5, and this function returns an absolute value of that. Okay, so just a moment. If I did this, we get 2 because 2 is already a positive number. But you don't have to actually guess, right? So for some of them you can guess. There is even a max. Oh, you would think, okay, let me try to use max. That probably returns a maximum value, right? But in order to get a maximum value, I have to give some values to that function. So you can try to guess 3, 7.5, 100, minus 2.3. And we're asking which one of these is the largest, and the max function gives us 100. But again, you don't have to guess. You can ask for help pages of this function. You can say, help, tell me what ABS does. It tells you that this is a built-in function and that you have to give it a value here. This X is a value, and then the function will return the absolute value of the argument. We're gonna get to what argument means, but just think of it as value. You give it a value. There's some of you that are unmuted. Before I blocked unmuting, can you please mute yourself, just because I hear some noises, otherwise it's fine. Like Sarah and Arta. So if you can unmute yourself, that'd be great. Okay, so what did we learn? That if you wanna know in a core Python, what are the functions that are already there, use this, not that, I'm trying to go back. There it is. Dir underscore underscore build underscore underscore is gonna give you all the functions that are in the core Python. And for particular function that you find there, if you want to know what exactly it does, then you just do help. Help is another function. Okay, you can actually find it. Surely it is here. There it is, help. It gives help pages on these, and then inside you will give a name of the function. For example, this one is another one that we can guess. POW stands for power. It tells you that if you give it 2 values, base and exponent, it's going to return base to the exponent. So it's exponentiation function. All right, so these are the functions. I started with the functions because the first thing that we did is we call the print function, because you basically can't do anything much without it. But let's backtrack actually and see what else Python knows. Does it know the most basic things such as numbers? Does it recognize integers, floats? Does it know arithmetic, and so on? Okay, so let's start with the most simple thing. Again, since we are just playing, we're not going to be writing this in the code, but I mean in the file, because we're not going to be saving it. But let's see what Python knows. Okay, so let me make this like this, clear up, pretend we are changing the topic. Let's see if it knows basic arithmetic and numbers. Okay, 10 plus 2, all right, it knows that it is 12. By the way, as you can see in Python shell, it's a place, again, you can think of it as a place where you can communicate with Python. In other words, you put one command, you press enter, Python immediately evaluates that expression or that function call and displays the result. So this is what happened here. We have Python, I did 10 plus 2, I pressed enter, Python evaluated that expression and displayed it, okay? If I try to do it here, I'm just gonna backtrack this and go to the file where we had this. And as the next line, we just learned that Python knows how to do 10 plus 2. Okay, so this is another program, I just saved it. By the way, to run the program that is in the file, so now right now we are in the file called, mine is called let's2.py. So this is a Python program. And I saved it, but you're not gonna see me going here to file, save, because I know the key combination, so you should do it too, because you have to be saving all the time. In my case, it's whatever, Comm S to save. Okay, probably is Control S if you have Windows. All right, so this is a save program. Let's run it and see what happens. Run module, we come here, and it only prints hello world. This is a type of confusion that the new programmers may struggle with and wonder, why did it not print 12? I mean, when we are here, it printed 12, okay? So this is because when you are in the shell and you type any expression, Python is going to evaluate it and display the result. Whether you want it or not, it's going to display the result. Inside of the program that you are making, like here, Python is only going to display, it's still going to, you may think, oh, it didn't do this line. Yes, it did. The program ran and it did execute 10 plus 2. But inside of your code, when you're writing a program, Python is going to display or print only what you tell it to print, okay? Because this part, when you're making a program, it's not for you. Probably, I mean, it could be, but it could be you're making a game for your friend. You don't want every single line of your code to be displayed, some calculations that you are doing, okay? Your code is going to display only what you tell it to display. So if you wanted to display the result of this expression, we would have to put it inside of the print statement. So in this case, run module, it's going to now do both. Okay, but when you're in a shell, like we are right now, it's gonna display whether you want or not. You evaluate expression and Python displays it. Okay, so back to figuring out what it knows. It knows how to add 2 numbers. It knows how to add 3 numbers, arbitrarily many numbers. Let's see this. It knows, let's do 2 plus 2 plus 2 times 2. Does it know order operation that you learn already in primary school? Okay, it seems that it does, that you have to do multiplication first and then addition, because if it just was going from left to right, we would have here 2 plus 2 is 4 plus 2 is 6 times 2 is 12. So it knows order of operation. I was told that this was called here, these rules are called bad, order operations are called BADMAS, meaning that you are doing brackets first. So if you have the order operation obviously is changed with the brackets. So brackets have the highest precedence, then exponentiation, then division and multiplication have the same order preference, then addition and subtraction. So if we wanted to do these additions first, we can change that with parentheses. And it seems this is just to demonstrate that Python knows these most basic things. It behaves, and this is again a nice thing about Python, it behaves the way you expect, but then again, all the programming languages do this, they know the order operation. All right, let's do this, 2 times 2 times 2 times 2, that's 2 to the 4. Okay, so you can multiply more than one element, but interestingly, and this most programming languages don't have, it has, so you have seen that Python has a plus operator that you can apply to numbers. It knows multiplication that you can apply for numbers. The same applies for minus and the division, but it also has exponentiation operator, which other programming languages don't have. So 2 times 2 times 2 times 2, that's 2 to the 4. And if you wanted operator exponent operator in Python, it's this, you use 2 stars. So this is 2 to the 4, okay? So you get the same result. So here's another one. I said the Python knows division. This may be a small surprise, the fact that there is exponentiation operator to those who program in other languages like Java and C. Then division, here's again a place where Python behaves differently from other programming languages. In other programming languages, if you have 2 integers like we have here, 3 and 2i integers, or whole numbers, whatever you call them in school, in other programming languages, this does integer division. It would give you 1. But Python doesn't. It just does the plain division, because Python is basically trying to do what it thinks most people would want. If I want to divide 2 numbers, if I'm using a division operator, then just do division, right? So the result of 3 divided by 2 in Python is 1.1 as you would want most of the time. If I'm using division, I want to get the result. I want to get the result of the division. Okay, so let's go back just a little bit to exponentiation, just because that's one way to create big numbers. So let's look at this. So we saw that it knows this, 2 to the 4 is 16. Here's another thing that may surprise those who program in other languages. And actually, this is a very nice feature of Python. So normally, if I was in the class, I would ask you, what do you think happens now? And many people would guess, those who programmed before, because those who haven't would think, okay, we get a result of 2 to the 2000. But there is a huge number. For example, 2 to the 2000 is a bigger number than number of atoms in universe. The number of atoms in universe is about 2 to the 200, something like this. So this is way bigger than the number of atoms in universe. So it's unlikely that you're ever going to need number this big. But still, so it means so let's see what happens. In other programming languages, when you press enter, this crashes, but it doesn't in Python. So, and here's a lesson, and this is not just for curiosity, this is something to remember about Python. So we learned that Python knows, what did we learn so far? That Python knows integers. In fact, we even learned that it knows reals, because the result of this operation, 3 divided by 2, is 1.5. But what we learned by this, actually, is that Python can handle huge integers, unlike other, you're not going to get a crash, unlike other programming languages. In fact, Python, what I want you to remember from this is that Python can represent integers exactly. There is no loss in any, if you're working with integers, you will never run out of space. Basically, integers are represented exactly in Python. They are not approximations. And I guess your whole memory is a limit, but these numbers of such size don't really exist. I mean, they exist mathematically, they exist. But yes, so integers are represented exactly in Python. Okay. All right. So let's have that in mind. Integers. So, and here we have expression that works as you would expect in math. This is what you want, right? Okay. So let's contrast this with this 2.0 to the 2000.0. Mathematically, these are completely identical expression. Completely identical. Okay, so in mathematically, there's no difference between these two expressions. We should get the same result. But computers don't have infinite memory. So some things are approximations. Okay, so you get approximation of the truth. Or even worse, you get a crash. So this is where we get a crash. Okay, so you may wonder why this happens. So this brings us again to what type of data Python knows, what type of, in particular, we are looking at what type of numbers Python knows. And we have seen that it knows integers and that it knows reals. Okay, let me give you just so it 2.5 times 100.75. Okay, so we are working with real numbers. So it knows reals. The difference, why it was able to handle this and it was not able to handle this, is in the way these numbers, these data types are represented in the computer. Okay, so in Python, remember, integers are represented exactly. There is no limited space allocated to integers. Integers are represented exactly. Real numbers, you get a limited space to represent a real number, okay? By the way, they're not in programming languages, again, these are not called reals, they're called float, okay? The way that, in a sense, they are floating, the data type float is an approximation of a real number, okay? So real numbers are represented in a limited amount of space, which brings me to a couple of slides that I have that I would like to show with you. So let's see what we have seen so far. We have seen that Python has these built-in functions, that the way to use them is to call them is you call them by their name, and then you put parentheses and anything inside of parentheses that that function may require. You have seen that there is this, we haven't seen yet, I'll show you that, that there is exponentiation operator and so on. So you have seen some algebraic expression that Python knows to do on numbers, on integers and reals. We haven't got there yet, but here, representation of numbers in Python. So this is what I was talking about right now. There are two types of data. Integers, they can be represented exactly. So there's no limits to the size of an integer in Python. The limit is your own memory. That's your limit of your computer. So there's no limit in representation. Integers, they are represented exactly. Floating points are used to approximate the real numbers. Okay, so basically, you don't have to memorize this. All you have to remember is that when you are working with reals, that you are actually getting approximation of a real number. It may not be exactly the number that you're hoping to be working with. All right, and if you want to know how it is represented, you basically get 16 digits of precision when you're representing a real number, and then you get times 10. In the range you get is from the tiny number to the huge number. The range you get is 10 to the minus 308 to 10 to the 308. But the exact number of digits you get is 16 to 17 number of digits. I mean, I believe this 16 to 17 actually depends whether your number is negative or positive, because a minus is going to take one digit of precision. And to give you an example, if you do, let's see, 112 points, and then you can have another 10 digits there or something else, or you can have 0.00 and then you can have another, I don't know how many I said, 10 more digits and so on. All right, and then you can do times 10 to whatever you need this 10 to be. You don't need to remember this, just keep these two things in mind. Integers are represented exactly, reals are approximated by this floating representation that gets limited amount of space in the memory. Okay, so first off, you may wonder why, okay? So you may wonder, why is it that we represent integers exactly? Why did we make that choice? Why did whoever designed this program and all the other programming languages made this choice that reals are approximated and get limited amount of space in the memory? Normally, I would ask students here to answer. I guess in the future I can try that. But right now, I'm going to give you an answer. And it is, if you pick any one integer, pick any integer, no matter how big, okay? So this one here, I don't know how many digits it is, But as soon as you pick an integer, the number of digits in that integer is finite. It's a constant. And as long as something is a constant, we can hope to represent it in a computer exactly, okay? So if you're representing any one particular integer, it has a finite number of digits, therefore it can be represented in the computer. Okay, so, all right. What about real numbers? You can pick a real number, just one real number that has infinitely many digits. So nobody has infinite memory. This concept doesn't exist. So even a simple number such as a third, okay, if you're going to represent it with that dot operator, it has infinitely many digits. So we can't even represent exactly. There are real numbers that you cannot even represent a single number in the memory exactly. You may say, okay, but we can find different ways to represent numbers such as rational numbers. That is really true, because rational numbers such as 1/3 are comprised of two integers. So we can actually work with them by representing exactly two integers, rather than working with 0 point infinitely number of threes. But there are numbers, for example, irrational numbers that have infinitely many digits that you cannot represent as a rational number, division of two integers. And they truly have infinitely many digits that you can't really predict, or think of pi, or think of e, the base of a natural algorithm. These numbers have infinitely many digits and cannot be represented in any computer, because every computer has bounded memory, has a constant size memory. No matter how big it is, it's still a constant, okay? So for that reason, there's not even a hope to represent real numbers exactly, so you might as well limit it from the beginning, okay? So that's the reason, by the convention, why real numbers are represented in this floating point representation that I just showed you. Okay, why should you keep this in mind? You should keep this in mind when you are working with real numbers, because you should keep in your mind that you may not be getting exact result, okay? So let me give you a small example of that. For example, 0.25 minus 0.5 minus 0.25, we are working with real numbers, and we get a correct result in this case. But if you do 0.3 minus 0.1, see here what happens. We didn't get 0.2. Okay, again, this is not something you have to worry about. This is not something that you have to memorize. It's not like on exam, I'm gonna ask you, are you going to get here exact results and here not exact? Don't worry about that. What you need to know is that the result you're gonna get is not necessarily exactly correct. It's approximation of, it's arbitrarily close to the correct result, because you see here 0.1999999. So probably if we count here, we're going to see these 70 digits of precision. So if you count this, if you look at this, this is arbitrarily close to 0.2. If we round this to, I don't know, 5 digits or something like this, we're going to get 0.2. So we get a number that is arbitrarily close to what we want. So this is something just to keep in mind when you're working with real numbers. One of the ways to deal with that is to use a round function. You're trying to round it to the closest number of digits that you want. And we're going to see round. Round function is one of the built-in functions that is there in Python. Okay. In fact, let me just already show you how to do it. So round is in the built-ins. If you do 2.3, it's going to round it. If you give it just one number, it's going to round it to closest integer. So round 2.3 is going to round it to 2, because that's a closest integer. Round 3.768 is going to round it to 4, because that's closest integer. By the way, at this point, I always get this question, what happens when you do a 5? And that depends whether the integer is even or odd. So the first part before the dot. The convention is that if the integer part is odd, then you round to the higher number. And if the integer part is even, then you round to lower number. Okay, so, oh, sorry, round, let's say sorry, I said even number, 6.5. Here I put 4. It should round it to a lower number. Okay, that's if you give round function 1 digit. It's going to round it to closest integer. But if you give it a second number, so what do I mean by that? Round. So let's see this. I want to round this. And I say, oh, round it to 5 digits. Okay, 5 most important digits. Okay, so you're going to see that this gets rounded to 0.2, what you want. So by working with the round, in fact, round, if you do it here, 0.3 or minus 0.1. So that's the first number that you're giving. And then the second number is number of digits that you want at most. And then it rounds it to 0.2. So if you're using a round function and you give it one number, it's going to round it to the closest integer. If you give it, if you give it 2 numbers like 2.3, 4, 5, 6, 7, 8, 9, something like that, not comma, but point. Let's actually do this. So and then I say, give me 6 most important digits, round it to 6 more important digits, you get 12.3.5.7, 7, and then this 89 was rounded to 9. Okay, so round is a useful way to deal with the fact that you are working with the approximate numbers. Okay, so where were we? Let me take a break. You can take on some questions because I'm going to take some questions soon. Let me see. All right, so I think at this, oh yes, there is one more thing I wanted you to notice. And it's here. So notice a couple of things. Notice that when we did 2 plus 3, these are 2 integers, we got an integer. When we do 3 times 4, we have 42. We are multiplying 2 integers, we get an integer. But look at this. You saw 3.2 that so 3 is an integer, 2 is an integer. When we do division, obviously we get a float, we get a real, because the result is a real. But even if we are dividing 2 integers, we are getting, notice a dot here. We are not getting, so for example, 4 times 2, we get an 8 without a dot. So the result of multiplying 2 integers is another integer, okay? But the result of division is always a real number. It's always a float, okay? Even if the result of division actually in mathematics is a whole number. So 4 divided by 2 is 2. And you may wonder, so again, that's a convention. They decided when they were using Python that if you are doing multiplication, addition, and division on integers, the result is always integer. But when you are doing division, no matter what your operands are, even if the integer, both integer, of course, if they're reals, that the result will always be a real. Again, you may wonder, why is that? Why did they decide by convention the result of division is always a real? And that actually goes back to math. It goes back to the fact that, what do I mean? To the fact that whenever you multiply 2 integers, you will always get an integer in mathematics. So integers are closed. The expression for that in mathematics is that integers are closed under multiplication operation. What it means that if you start with a set of integers and you apply multiplication operation to any pair of numbers in that set, the result stays in the set. It's still an integer. The same is true for subtraction and addition. If you start with a set of integers and you apply multiplication or addition or subtraction to any 2 numbers in a set of integers, the result stays in the set, okay? That is not true for division. If you started with a set of integers, and if you take two integers and apply division operation, you are not necessarily staying in a set of integers. The result may move, the result may be in a set of reals, not anymore. So division operation is not closed when applied to so in the set of integers, it's not closed under the division operation. So for that reason, to remove this ambiguity and guessing, they are always producing a real after the division operation. Okay, all right. So, and it goes, what I'm going to show now is, it goes to a question that we had. So we were showing that if you do 3 divided by 2, you get 1.5, but sometimes you want integer division, okay? Integer division is very useful. So what is integer division? If you divide into integers, it's like saying, I'm gonna cut off all the decimal parts, okay? So that's what integer division does. Python has an operator for that, and it's basically two, I don't know, is this slash or backslash, 2 of the lines that you see on the screen, and a result is an integer. So here we are doing integer division of 3 and 2, it's 1.5, you cut off decimal places and a dot and you get an integer 1. Okay, so 4 divided by 3, unlike round, it doesn't go to the highest integer. It really cuts. So let's see, 4 divided by, this is a wrong example. What would be a good example? I'm bad at this. Okay, 7, 8, no, sorry. 7 divided by, I'm not good at these things. 7 divided by 4. Okay, this one. 7 integer division 4, what I wanted to demonstrate is not like a round. It's not going to go to the closest integer. It really cuts off decimal places. You get that it's 1. Okay, so when you're using integer division, if a number, 2 numbers are actually not divisible, there is a remainder. This is something the way you were doing division, I don't know if you remember, in primary school, before you knew real numbers, the way you would say this is, what is 7 divided by 4? You would say it's a 1 with remainder 3. What's left over is 3. So what you wanted, if you wanted that remainder, and that's actually extremely useful in programming languages. If you are new to this and never programmed before, it seems like this is a strange operation, this remainder, who cares about this? I never used this since 2nd grade primary school, but in fact, in programming languages, it's everywhere. I can tell you now that in your assignments, in your tests, it will be everywhere. So you need to know remainder operator. Okay, so I mean, you need to know how it works. Here's how you do it in Python. So you are asking, what's the remainder of division of 7 and 4? We said that that's a 3 because 7 divided by 4 is 1. 1 times 4 is 4. So what's left to 7? It's 3. Let's give a couple more examples for some. Every year, there are many students who somehow have some issues with this. So let me give you a couple more examples. For example, 11, integer division, remainder of operation of 11 and 3. So you ask yourself, what's 11 integer division 3? That's 3, right? 3 can fit 3 times in 11. So 3 times 3 is 9. So what's left from 11 is 2. So remainder is 2. What about integer division 11 and 4? Okay, 11 integer division 4. So 11 divide 4, if you're going to do integer division, is 2. So 2 times 4 is 8. So what's left over is 3. Okay, 11 integer division 5. Last example. This is 5 fits 2 times in 11. In other words, 11 divided by 5, integer division is 2. 2 times 5 is 10. What's left over is 1. And actually, here's my last example. It's that 12 divided by 6. 12 and 6 are divisible. So 12 divided by 6 is 2. 2 times 6 is 12. So 12 minus 12 is 0. So the remainder is 0. Okay, so you need to know remainder operator. It will be everywhere. Okay, so those are the operations that Python knows. What we have seen so far, we have seen so far that Python knows. I mean, this sounds. I mean, we want to know what it already knows, and it's kind of not the most exciting lecture, but we have seen that already there are some differences from math and the way Python deals with numbers. So we have seen that Python recognizes already 2 data types, okay? It knows about integers, it knows about reals that it calls floats. It presents them as floats. And and if you give it 2 numbers, either an integer or a real, it knows how to do some of the arithmetic operation on it, like a plus, minus, exponentiation, multiplication, integer division, remainder operator. What else can you do with numbers? Numbers can be compared, okay? So it knows the standard comparison operations. So 2 divided by 2 less than 3, you're asking is 2 less than 3, it's giving you true, okay? Is 2.5 less than equal 2.5, okay? Hopefully you know that this is true. Okay, and let's say 2.5, 2.4, strictly less than 2.4, that is false, okay? So here actually you are seeing yet another data type. This is a boolean data type, true and false. It's a certain type of data in Python, okay? So far you have seen 3 data types: integers, floats, and Boolean. So true and false. Boolean, you can work with these Boolean data types. We're gonna see that at some point. All right, so what else did I want to show you here? Oh, you may wanna ask if 2 numbers are the same, and you may be tempted to write this. This is really important. 2 equal to 2, you're gonna get a syntax error. And this I will repeat throughout the semester in all the programming languages. This operator here, equal, does not mean equal. It means a sign. So in some ways, I guess it would be a pain, but we made a mistake by picking equal sign in programming languages. The sign should be like this. Assign what's on the right-hand side to the left-hand side. And in that case, you would realize that this doesn't make any sense. If I put a variable name here, this makes sense because it's saying, go to the right-hand side, number 2, assign it to variable X. And then a variable X becomes a 2. But unfortunately, we didn't pick that because I guess it would be cumbersome to be drawing this arrow, okay? Instead, this is actually equal sign is used as an assignment operator in programming languages. So the way you should always read this is a sign. So whatever is on the right-hand side of this operator should be assigned to the left-hand side, okay? This gets to the variables, but I'm gonna, I'm gonna get to variables in a couple of minutes. So, put this on hold for a moment. But remember that equal sign is not equal sign doesn't mean equal. It's not asking if something is equal in programming languages. It is an assignment operator. It always assigns what it tries to do is assign what's on the right-hand side to the left-hand side. If you really want to ask, is something equal, then you do equal sign. 2 equal 2. You're asking, are they the same? You get true. 3 equal 2. You're asking, are they the same? You get a false. If you want a symbol for not equal, is 2 not equal 2? You are using, this is a sign for that, exclamation mark, and an equal is asking, is something not equal? And we get here true. You're asking, is it true that 2 is not equal to 3? And that's true. Is it And you can ask many similar questions. So what did you see? That you have less than, equal, less than, greater than, here's less than equal, here's greater than equal, here's equal, and here's not equal. These are the Boolean operators, or comparison operators that you can apply, on the numbers. Okay, so here's syntax error, because this doesn't really, I didn't put any numbers. I'm going to, all right, so this I'm going to, okay, so here's, let's go back to this dir. How much time do we have? Okay, dir, built-ins underscore underscore. And here's a very useful, so in addition to dir and help and print that you're going to be using throughout the semester, I hope, here's a very useful information, very useful data type, a very useful function that I hope you're going to use throughout the semester to understand what you are working with. The function is called type, okay? And again, if you want to use any function, you put a function name, you open parentheses, close parentheses, and you put inside what a function required, which normally function description tells you what it requires, but I'm going to tell you how to use this one. This function returns what type of data is the particular, everything in Python is objects, and I'm going to get to that. But for now, think of object as just values. What type of value this is. So if you put a number like this, 232, Python is going to tell you that's a value that I recognize. It's what type of data are you working with here? What type of data is this 232? It's telling you that this is an int. Okay, so there is a bit of syntax here, but it's in essence, it's telling you that 232 is an integer. Okay, so you can do that for every type of value that exists in Python, even later on when we design our own data types. For now, we are working with data types that somebody else created for you, and they created integers and floats. And so let's see here, 2.5, 2.4, it's telling you that that's a float. All right, and finally, we did see another data type, and that's a true with capital T. It's telling you that that is a value called Boolean. Okay, so far you have seen 3 types of values, so 3 types of data that Python recognizes, which is integers, floats, and Boolean. In fact, those who were in the tutorial, my beginner's tutorial, have also seen a turtle type object, but that doesn't really matter. Let me show you actually what we already discussed. This function also tells you the result of operation. The result of some operations, again, is some object or some data. And if you have an operation here, so like in 3 divided by 2, is going to tell you the result of that operation is a float. Remember, we were looking at integer division. The division always gives a float, even if you're, but 3 times 2, the result of this operation is an integer. Okay, so remember that type is a useful function that can tell you what type of data you're dealing with. That brings me to the last topic today that is very important, because what we want to do and what we're going to do in the next class is how do you design your own function, right? So somebody made all of these function, print, power, so on. So for the rest of the semester, what we're going to be doing is actually designing our own functions. So the next class, we're going to learn how to design functions, but in order to design functions, actually do anything useful in any programming language, we need to know about variables. And it goes back to the question that somebody asked about variables in Python. Do they have a type or not? Okay, so let's see this. Here's how you create a variable in Python. You have to assign it a value, all right? The way in other programming languages, to create a variable, you say, here's a variable name, and this variable is going to be holding integers, for example. So you would say int x, okay? This would mean create a variable x, And what I'm going to be storing in that variable is always an integer. And that's how you create a variable. If you don't do this, later on, if you want to do x is equal to 2, you're going to get a syntax error in languages like Java and C. All right. In Python, you have seen that so far in this, I can even restart the shell. You can go here and restart the shell, then it erases everything that we've done. Nobody ever created, and this is called declaration. This int x in other languages means I'm declaring x is a variable and it's going to hold integers. It doesn't work like that in Python. In Python, you create a variable by assigning a value to a variable, okay? So remember, this is an assignment operator. So how do you create a variable? On the left-hand side of the assignment operator, you're gonna put a variable name. You're gonna pick that name. In math, you always start with x, okay? So x, assign what to x, whatever I put on the right-hand side. I want x to be the result operation 2 plus 3, okay? So x should be 5. So you always go on the right-hand side. If it's an expression, you evaluate it, and the result of that expression you assign to the left-hand side. I should have started with sample, and here it's telling you that it's 5. Of course, the simpler thing to say is let's just do x is equal to 5, or in other words, assign 5 to x. All right, by the way, here's something else to notice in Python. Normally, to get a value of the variable, you have to do print x, but because we are in the shell, even if I just put x, already that is an expression. Python shell evaluates it and tells me the result of that evaluation. What's in x? It's 5. It displays what's in x. All right. Okay. So here's something I'm going to define. Let's say I want to know what is, what do I have here? I want to know what is x times y. All right. X is 5, x times y. Okay, Python is going to complain. It says, I don't know what y is. Obviously, I never assigned anything to y. In order to use a variable, you have to create it. And in Python, the only way to create a variable is to assign value to it. All right, so let's do y is equal, for example. So what do we have right now? X is currently 5. Let me clear this up. X is 5. Let's say y is equal to 2 times x. Again, not equal, assign. All right. So what did we say? This is assignment operator. You go to the right-hand side. What is x? X is 5, 2.5 is 10. Assign 10 to y. That creates variable y if it hasn't existed yet. Y is there. Let's check that it's 10. It's indeed 10. So here's something that is completely obvious to everybody who programmed before that may be super confusing to those who are programming for the first time. Those who programmed before, this is so natural, it becomes second nature that you forgot that this could have been confusing at one time in the past. Okay, so far everything should be clear to everybody because this is the same as math. Okay, but let me now change x. All right, so x is 1. All right, so if I'm asking what is x, x is 1, that is fine. But now if I'm asking what is y, okay? Here's the place where those who programmed before are thinking, why is she even asking me this? And those who didn't program may also ask, why is she even asking that? Okay. And here it is. Y is still 10. For those who think of it mathematically, they may think x is now 1 and y is defined to be 2 times x. So y should be 1. Once I change x, but that is not the case, okay? The only way in programming languages to change a variable, it never gets changed like that a posteriori. The only way to change the variable is to assign a new value to the variable. So here, meaning you have to use equal operator. So here we assigned 1 to x, okay? So x changed, but we didn't assign y anything new to y. Y was assigned over here when x was 5, so y is still 10, okay? So the variables are created by assigning values to them, and the only way to change variable is to assign value to them, okay? So it always holds the last value you assigned it to. You can think of variables in little buckets. Here's a bucket called x, here's a bucket called y, and with this assignment operator, you're putting that value in the bracket. The only time the value is replaced is when you use another assignment operator. Okay, so actually now we are going back to the question that the student asked about the types. So let's look at this. Right now we have that x is 1 and y is 10. You can use that type function that I showed you on the variable. It's telling you what's stored in x is an int, what's stored in y is an int. Okay, but now I can say, oh, actually I changed my mind. X is going to be 2.34. All right, nothing, there's no problem here. Again, those who didn't program before, they think, okay, sure, that sounds great, why not? But actually, this is not possible in other programming languages. Well, these type programming languages like Java and C. Okay, so if I do now, tell me what variable x is referring to, what type of value is inside of the variable x. It's telling you now, right now, what's in x is a float. So before we had that the variable x was an int, and now we have that it's what's inside the variable x is a float. I can even go further. I can say, oh, actually, x, I'm going to make it, I'm going to assign this Boolean value to it. And right now, if I do what's in x, oh, it's a Boolean value in x. All right. And finally, let me even give you an example with the last thing that we have seen, which I said was strings. Remember, we have seen another data type, not just numbers and Booleans. We have actually seen text or strings, which is a data type. It's a text that you put let me say, I am a string. It's a text that you put between the quotes. It's a certain type of data, textual data. Okay, and right now, if I ask what type of data is stored in X, it's a string. All right, so to remember from this is that Python, to create a variable, you have to assign value to it. The only way to change the value is again by assigning something else to it. And here's something. So what you can see from this is that in Python, variables don't have type. Because here we see that x was an int, then later on x had a float, then later on x was a Boolean. So variables themselves do not have type. It's the values that are stored in variables that have type. So when in x we had value 10 stored, it was telling us 10 is an integer. So values have type, variables don't have type. So y here, why am I saying y here? Oh, so here, when 2.34 was stored in x, it was telling us x is a float, that it's not x, the value that is stored in x is a float. So I'm gonna end with that, today's lecture. I'm gonna let you ask the questions in the last 5 minutes. So again, variables don't have type in Pythons. The objects or the values that are stored in variables do. Okay, so I'm going to stop sharing. And I will let you ask your questions. By the way, do not worry that I'm going to, you guys asking questions, I'm going to cut it out of the video because otherwise I would have to ask all of you. So you don't have to worry that please ask the questions that you're going to look silly or anything like this. I'm going to cut it out of recording. I don't want to ask all of you permissions for that. I don't want to put you in the position that you have to give me permission. So these sessions, when I'm letting you ask the questions, don't worry, I'm not going to put them on YouTube. So please ask your questions freely, especially once I let you unmute yourself.